Hi guys, this is Mr. Robeson here. We're going to start Unit 7 here, which is all about hypothesis tests. So in this section, we're just going to worry about stating hypotheses and stating what the parameter stands for. So we're not actually going to get into the test yet. We're just going to start off by stating what our hypotheses are for the test. All right, so what is a significance test, or what is a hypothesis test? It's a formal procedure for using observed data to decide between two competing claims. And these competing claims are called our hypotheses. All right, so these hypotheses are always statements about a parameter, like a population proportion P or a population mean mu. So it's always about P or mu, so it's not about P hat or X bar. Like, we will use those, but when we're going to state our hypothesis, we always use P and mu. So remember, if you don't have that character, you can write mu like that. That's fine. All right, so an example here. Mr. Robeson claims that over his lifetime, he makes 80% of his free throws in trash get ball. So trash get ball is a game we usually play in the classroom where the garbage bin works as the basket, and we have tennis balls, and we stand a certain distance away and try and throw the tennis balls into the garbage can. We generally play this in class when we're doing games and things like that. Sorry, we didn't get to play this year. So what is Mr. Robeson's claim? Well, he claims that over his lifetime, he makes 80%. So it's a percent. So percents are P's. So that means this P is the true proportion or population proportion of trash get ball free throws he makes. And his claim is that P equals 80% or 0.80. We usually use the decimals here, but you can also write 80%. Now, how can we go about testing his claim? How can we test his claim? Well, we would want to take a sample. In other words, have him take many shots. All right, so we don't just want to have him take one shot, because that wouldn't be enough to tell if he makes 80%. We want him to take many shots and see if the proportion, and that proportion would be a sample proportion, which we would call P hat, is close to 80%, or 0.80. All right, so it's probably not going to match it exactly, but if I take shots and I make 79% of them, and my claim is that I make 80% over my lifetime, then you know what, that's pretty close. You're probably going to say, all right, he could probably make 80% over his lifetime. But if I take a bunch of shots and I only make 50%, and I'm claiming that I make 80%, then you're probably going to think, wait a minute, that doesn't sound right. I think he might be lying to us. All right, so that's how we do hypothesis tests. All right, so today we are just working on how to state the hypotheses. So we have two hypotheses. The first one is called the null hypothesis, which we write as capital H with a sub-zero after it. Yes, sub-zero. The claim that we weigh evidence against in a significance test is the null hypothesis. It's what we start out believing. All right, so we start out being told this is true. The null hypothesis is true. All right, and then we're going to see, well, is it really true, or do we have evidence for what we call the alternative hypothesis, which is capital H with a little a. Sometimes we can write this as capital A or lowercase a. It doesn't make a difference. So the claim that we are trying to find evidence for. So we're trying to find evidence for this other claim. All right, so our null hypothesis in this class is always equal to 0, or equal to whatever they tell us. So it's always the equal sign. All right, so our null hypothesis, colon, P equals 80%. All right. For our alternative hypothesis, we have actually three things that can happen. All right, we can have that we think that the P is greater than that 80%. We can think that the P is less than the 80%, or we can think that the P is different from the 80%. So these greater than or less than are called one-sided tests because we're only looking one way. Is it above it or is it less than it? These not equal to, we can look two different ways, so it's a two-sided test. It could be less than or greater than. That's why we say it's a two-sided test when we have the not equal to sign. So if we're looking for greater than, then we could have the words more or increase, or we could have the words greater than. If we're looking for less than, We could have the words less or decrease or less than, something that tells us that it's going to decrease. So let's look at the example here. And then all the rest of this PowerPoint is just examples. What is the null hypothesis for Mr. Robeson's claim that he makes 80% of his shots? If we believe the true value to be less, what is the alternative hypothesis? So first thing, before we write hypothesis, we need to define the parameter. So P is the true proportion. And I always start off writing the word true. It's the same thing as writing the word population, but true is shorter. So true proportion of shots Mr. Robeson makes in trash kickball. All right, so now we're going to write our null hypothesis and our alternative hypothesis. So H sub 0 and H sub A. So our null hypothesis is always equal to, all right, an alternative we're going to have to figure out based on context clues. So he claims that he makes 80%. So we're going to start off with equal to 0.80. We believe the true value to be less. So we're going to say that P is less than 80%. All right, there we go. That's it. That's all we're doing for this unit, or this section at least. All right, so some other examples. So first, define the parameter of interest. So that would be P or mu. And then state the appropriate hypotheses for performing a significance test. So our null hypothesis and our alternative hypothesis. What are they both going to be? All right, so at the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in the field after the growing season. Managers wonder if this change will cause the mean weight of the pineapples grown in the field this year to be different. All right, so it looks like we're talking about mean. All right, we didn't have any percents, but we did talk about mean. So we're going to say mu is the true mean weight of pineapples harvested from one large field. Harvested from this field. All right, and now we're going to state what our hypotheses are that we would like to test. So we start out always with equal to. So we're working with mean, so we're going to use mean, mu, equals. And we were told last year was 31, so we're going to start off saying, well, 31 seems like a reasonable answer. Now we want to know, is it different this year? Because we changed the irrigation system. We have a different irrigation system. Will it change what it's going to the mean weight? So we say the mean is not equal to 31. We don't know if it's going to increase. We don't know if it's going to decrease. We just think it's going to be different. So let's just check and see, is it different? All right, next one. A poll worker wants to know if the approval rating of the president has decreased since when he was inaugurated. When he was inaugurated, we had a 57% approval rating. All right, so we're given a percent. So that means we're working with P, a population proportion. And this is the true proportion. And we're talking about people that approve of the president. So who approve of the president. All right, so our null hypothesis will be that P equals something, and our alternative hypothesis will also involve P. All right, so we start off saying that it's 57%, so we're going to set it equals 0.57. We want to know, has it decreased? So that means less than. P is going to be less than what it was before, and what it was before was 57. So we say P is less than 0.57, and there's our hypotheses. All right, let's do two more. All right, so 10 years ago, the average weight of someone on the high school football team was 200 pounds. And let's see, we're talking about the average weight. The football coach thinks the average weight of the players on the football team has increased. So we're talking about an average, so that means we're using mu, mean, average. And mu is the true mean weight of, let's see, high school. Players on the high school football team. People on the high school football team. All right, So we've got a null hypothesis and an alternative hypothesis. Our null hypothesis, we're going to use mu, is that it equals, well, what we were told it was before, 200 pounds. Our alternative hypothesis is we think that it has increased. So that means this mean is now going to be greater than 200. All right. Last example here. 20 years ago, polls suggested that 55% of Americans worried that climate change caused by humans was a dangerous threat. Researchers would like to know if that number has changed significantly. All right, so we're talking about the proportion of people who are worried about climate change. So P, it's a proportion, it's a percent, is the true proportion of, and we're talking specifically about Americans, of Americans worried about climate change. All right, and now we have a null hypothesis and we have an alternative hypothesis. So we're going to, both of them will involve P. The null one will be equal, and we've said it was 55% before, so we're going to say it still equals 55% or 0.55. The alternative, we want to know just has it changed? So it could be greater than or less than, so we use not equal to 0.55. All right, so we've looked at, let's see, applications for sports. We looked at applications for farming last time. We looked at applications in politics. We looked at applications for science. So these hypothesis tests can be used in a lot, and they're actually used in all sorts of drug trials and things like that for like vaccines and that sort of stuff too. So they're used a lot in science and politics and lots of different things. All right, so that's how we state the hypotheses. Next time we'll figure out how to check them.